All right. How many of you have heard of sigops before? Okay, pretty much everyone. All right, maybe this will just be a quick review for most people, but maybe not. All right. So does anyone know what this is a picture of? A signature, right? Okay. And so like this is a normal signature, but Bitcoin transactions also have signatures in them, right? So a Bitcoin transaction has a signature on it. Sometimes those transactions have more than one signature on them. Sometimes they have a lot of signatures on them, right? So you have a Bitcoin transaction, you have some number of signatures on your Bitcoin transaction. Most Bitcoin transactions have at least one signature on them unless you're a degen who's trying to get a mint ahead of everyone else and trying to optimize on the amount of weight you're putting in your transaction, and you're hoping that the amount of fee you're paying / the obscurity of what you're doing will protect you from getting sniped in the mempool. Okay, that's this whole side story. We're not talking about that. But most transactions have a signature on them. So in this talk, I want to talk about something called sigops, more like sigoops. Cool. A little bit about me. My name is Nifty. I also go by Lisa. I am a block streamer, longtime Core Lightning contributor. I started a education project called Base 58, School of Engineering a few years ago, and I run Bitcoin++. Also some interesting background. If you know what ISIC is, I'm an ISICer, and I am a not graduate from the Recurse Center in New York City. Kind of like a lot of stuff. Cool. But let's talk about sigops. So what is sigops short for? It stands for signature operations. What does a signature operation looks like? This is the most basic kind of signature operation you can do, which is you have a pub key and you call op check sig in it, right? So any kind of op code in a Bitcoin script that is invoking a signature operation is called a signature operation. Hopefully that makes sense. Cool. Okay, so what are all the sig operations that exist in Bitcoin script? Well, there's the plain op check sig. There's also its favorite cousin, op check sig verify. We have op check multisig and then op check multisig verify in general. These are all of the, let's say, okay, yeah. So these are most of the signature opcodes that we've got. And so you have a signature in a transaction, you're going to have a pub key, and then you're going to call opcheck sig to verify if that signature isn't actually valid for the transaction given the pub key, et cetera, right? So that's a signature operation. And again, opcheck multisig is just like a normal signature operation with the difference that instead of checking one signature, you're usually checking a lot of different signatures. Cool. Okay, so the number of signature operations or number of times that you have to verify that a signature is correct is a signature operation, etc. Okay, so this is like a concept. Why do we bring this up? Okay, because in Bitcoin, we kind of have this accounting that we do around the number of signature operations that happen in a transaction, or more generally, as we'll see, in a block. And so there's kind of these rules around like counting sigops is sort of a thing that we do. So there's kind of, I went through a Stack Overflow post, so there's a Stack Overflow post that had some interesting, I don't know, so just kind of some clips from it because I thought it was a good explanation. So like if you have a check sig or a check sig verify, you count that as one sigop, generally speaking. So this would be one, right? And then if you have a op check multisig, well, this is clearly more than one signature. How many signatures, how many should you count for this, right? It's one opcode, but it's going to have more than one signature. So calling it just one wouldn't work very well. So there's some special rules about how many that counts for as your signature operations. I think in older scripts, they just count it as a flat 20. It's kind of like has a generic cost of 20. But in more recent things, it counts the number of public keys that are listed in the signature operation up to 16. And if you go over 16, you're in the 20 bucket again, which I think is kind of funny. I don't know. Like if you put 18 in there, it's actually going to cost you 20. So maybe you shouldn't do that. I don't know. Anyways, cool. Okay, so opcheck multisig, we have a different way of counting the number of signature operations that this opcode is going to make happen inside your computer, right? Cool. And the reason, okay, so anyways, we're still going through the accounting version of this. And then, so those are kind of the numbers, 1 and 20, if you're doing before SegWit happened. And then SegWit happened, and we had to multiply everything by 4 because we multiplied weights by 4. So now we're also multiplying signature operations by 4. So if you're using a pre-SegWit transaction script, you're going to multiply everything by 4. So now if you have an op check sig, it's going to be worth 4. It's going to count as 4. Again, this is like weird accounting. I don't know. These are accounting rules. These are the rules. This is how it is. I don't know why it's like this. So if you're doing a signature operation, not in a taproot script, not a non-SegWit script, it's going to count for 4. And then op check multisig is going to count for 80. Is everyone following? Got like numbers. We're adding things up. You count how many opcodes are in a script. And then why does that matter? So you get a number at the end of the day. You count up how many sigops happened in a transaction. It matters because there's a rule, a consensus level rule at the block level where you can only have 80,000 sigops in a single block. I didn't have time to look into exactly, apparently there's some more relay level rules. So there's kind of 2 layers of rules in Bitcoin. There's one that's like, I've made a block and it has to follow a set of rules so that other nodes will take my block. We call those consensus rules. There's another set of rules that are, I would say, almost like transaction relay rules. I think the more general term people use for that is policy, which is I have a transaction and in order to send it to the next person, it has to follow a different set of rules. Those are policy rules. I think there's different policy rules around sigops. Again, I didn't look them up exactly, so I apologize for not having exact information on that. But the consensus level rule is that if you have a block, all the transactions inside of it, all of the signature operations inside the transactions inside of a block, count them all up using this accounting method that we just went through. You can't go over 80,000. Is everyone following along? Makes sense. Okay, we got a sigops limit. Here's some fun kind of like side facts about sigops. If you have an if, else, and if statement, and I put, I don't have a slide for this, but if I put inside of here, can you see my cursor? Yeah. What if inside of here I had like an op check multisig? Let's just say that counts as like 20 for simplicity's sake. And then let's say I had an op check sig in this else branch. So it's an op if and op else. Are both of these branches going to execute ever? No, right? Only one. Only the op check multisig on the top that you can't see that I'm just waving in, or the one on the check sig on the second else branch is going to execute. If Bitcoin looks at this script, how much is it going to say how much is this going to count against my sigops budget, as they call it, like 80,000 is our total budget. How many is this altogether going to count against it? Is it going to count 1 or is it going to count 20? Anyone know? Who thinks it's going to be 1? Who thinks it's going to be 20? Who thinks it's none of the above, it's actually 21? Okay, the answer is it's 21. And the reason that it's 21 is that Bitcoin doesn't look at, whenever it's going through and it's counting the number of sigops that happen in a transaction, it doesn't pay attention to branches. It just counts the appearance of every sigop in a script, if that makes sense. So if you take a script and you know what the opcode hex number is for a signature operation, it scans through the script. It ignores everything else, and it just counts up how many of them and does some accounting on that, if that makes sense. So you could have more sigops in a script that never get executed that would still count against your budget, which is kind of interesting. Okay, I have one more maybe trick question about sig operations. How many sigops does check sig add count for? How many people have seen this opcode before? People are like, I know what that is. There's like a handful of people. Okay, so not a lot. So okay, this is a new script opcode that got added for TapScript, otherwise known as SegWit v1 scripts. And there's a rule according to the Stack Overflow post I read, which I'm assuming is right because Peter Willa wrote it, I think. Taproot scripts don't have sigop counts. So according to this post I read, you should be able to use op check sig add as many times as you want without it counting against your sigops limit, is my understanding. I should verify this, but there's question marks there. Cool. So we had some trivia things, right? So in pay to taproot scripts, sigops are not counted. Cool. Okay, so the sigops limit made the news last April 1st. And no, I don't believe it was a joke, because a big mining pool didn't make a mistake once. They made a mistake twice. And the mistake that they made, the sigoops, so to speak, that happened, is that, oh no, wait, sorry, this is just a graph of all the sig operations in blocks. This guy, 0xb10c, does some really great kind of miner level analysis. So he has an analysis here of, if you look at every block that's been mined in the last, I don't know, 130,000 blocks. No, that's math. Anyways, if you look at a bunch of blocks that have been mined, then you kind of graph how many sig operations were inside of each block. You can see that for most blocks, the majority of blocks that come through the system, the sig ops limits is is unimportant, right? They don't get anywhere close to this line, which is the limit. So for most miners, when they're building where they're building blocks, they're looking through all the different transactions that they could put into a block. They're picking them based on, I don't know, favorite child, amount of fees that you're paying them, bribes that you paid out of bound, whatever. While they're doing that, majority of the time, they don't have to worry about how many signature operations are inside those transactions. They can just put it in a block and move on with their life. It's not a problem. Every once in a while, we get really close to the limit. But in fact, back in April, this is from April 20, this is from last year. So April 1st, 2023, F2 pool mined a block. So they meant actually 2 blocks in April that they mined where they got bad block sigops, too many sigops. So they had 2 blocks that got mined where they took transactions and they did a bad accounting job and they went over the sigops limit and then they found a winning nonce for that block. So they found a winning block. And then once they had that winning block, they started telling everyone, hey, we just won a block, you know how blocks get propagated across the network. But as that block went to every other node on the network, they rejected it because they're like, no, this has too many sig ops in it. We don't want it. So basically, if you're a miner, that means you lost out on revenue of 2 blocks that would have generally been yours, except you failed one of the, I would say, fairly obscure consensus rules. Cool. Okay. So why do we care? Why are we talking about sig ops? Why is this an interesting thing to cover at a Bitcoin script conference? I think that they're really interesting from a perspective of, where did this come from? Why do we have them? Where did it get introduced? I think, I could be wrong about this, back in 2010, so very early Bitcoin history, they found transactions with a ton of opcheck sig commands. And what this was doing is, it was every node, when it gets an opcheck sig transaction, a transaction with an opcheck sig inside of it, it has to do work to verify that that signature is correct. So having a lot of signature checks inside a transaction means that every node on the network has to run that many signature checks before it can say, okay, this is a good block or this is a good transaction. So in some ways, sigops is one of the few places in Bitcoin today that we have limits placed on the amount of execution that's allowed inside of Bitcoin script. So I don't know if it was exactly related to this problem that they then added the sigops limit. So you can only do so many signatures in a block, and that's a way to prevent people from creating transactions that basically make too much computation happen across the network whenever those transactions get sent out, and basically clogs down every single Bitcoin node because they're sitting there calculating transaction signatures for minutes at a time because they have too many of them. So coming up with this 80,000 limit was, I believe, 20,000 limit, which then later became 80,000 when SegWit hit. I believe was a little arbitrary. I don't know, source needed on this. But the idea behind the sigops limit is that we want to place some sort of reasonable limits on the amount of computation that a Bitcoin script can cause other nodes on the network to do, right? And the reason for that is that that's costly, right? It doesn't cost you, it costs your node time and energy to process and to run these verification checks, right? Because Bitcoin is a don't trust verify network that's distributed. So every single node on the network has to run these verifications independently. So adding a lot of computation to a Bitcoin script means that you kind of create the cost on the network to verify transactions, et cetera, which is costly in the long run. Kind of a bad joke that it's like making your nodes do proof of work also. No, okay. Cool. So again, execution costs of Bitcoin script are a real thing that in general we kind of have hand waved over traditionally the cost of and had just like, okay, there's like a limit on how many there can be and that's just like a hard line in the sand. And that's how we will generally avoid these problems with the amount of execution that's happening. There's a few other places that you kind of have limits like this that sort of indicate similar things. It's not just the sigop limit. There's also a non-push op limit in a script, which means you just count the number of operations that happen. It can't go over 201. But I think so it just counts. Fun kind of side fact is this also counts the pub keys and multisegs. So those count toward an opcode limit. Anyways, how much execution you're doing, like there's a few limits on it. It's most of a count-based thing though. So how many operations are you doing? Let's count them. You can't do more than this number, hand wave. Cool. So why am I bringing this up at a script conference? It's because I think that as we start thinking about new scripts and new sorts of execution that we want to ask our nodes to do when we're considering new opcode proposals, I think it's interesting to ask about the amount of computation that each of those opcodes is going to be adding to the system, and maybe it's an opportunity for us to reconsider the costing function that we have for what a for what a operation costs, right? Right now, some of the most costly things are signature verification operations. But if we add something like check sig from stack, will that count towards the sigop limits? I think there's like some interesting questions there, again, around accounting of new scripts, et cetera. I think we all heard from Rusty earlier this morning, who had a really great presentation, or I think ideas about more in-depth ways to kind of do this costing of how much it costs to actually execute different scripts. That might be one possible way that we could move forward with how we're going to add or bring back new opcodes, et cetera, and make sure that we're kind of keeping our limits on the CPU of nodes on the network in check. Cool. Okay, I think that's everything that I have. I don't know how I'm on time. I have two things to show you on before I go. The first one is that I want to talk, I run this school called Base 58. I talk about Bitcoin engineering and protocol things. So if you thought this was fun, this class will be even more fun. We do hands-on stuff, and I explain how things in the protocol work. I have Udemy classes online, and I'm hoping, fingers crossed, when I get some time next week to finally get some more online classes out and available. I think we're doing a wallets class at the end of this month online. So if you want to learn about how hierarchical deterministic wallets work, we're going to talk about pub keys. I think we're going to do PSBTs. And yeah, that should be the thing. Maybe we'll talk about, I don't know if we'll talk about miniscript. That's a hand wave, maybe. And then the last thing is, if you learned, maybe hopefully you picked up some things today that might be useful for trivia. Base 58 is hoping a trivia tomorrow night over at the Bitcoin Commons in conjunction with Austin Bit Devs. So if you're around on Thursday and want to come try your luck with some friends at how much you know about how Bitcoin script, et cetera, works, come hang out on Thursday. Cool. Okay. I don't know if I have any time for questions or not. Are we good on time? I have 4 minutes. Okay, so maybe 2 questions if there are any. If not, we've got snack break, et cetera, before coming back for more talks. So great. Okay. Thanks, Gal. Yeah. What other obscure consensus rules? Your brain's like, I don't know. I honestly think this is one of the most obscure, weird consensus rules. And the way that I kind of found out about it was because of these bad blocks, if that makes sense, last year. Because all of a sudden there was news. It was news. It didn't used to be news. Yeah. the question, maybe I did, I don't remember if I repeated the question. Okay, but it was, yeah, anyway, sorry.
How would people, like, just last year go over that transaction? Is it
Yeah.
block templates?
So, so the answer has to do with something called the Coinbase transaction, which is the transaction that miners put together. And the default block template, starts getting into things I'm not like super the most expert at, but my understanding is that in general, if you're using Bitcoin Core, it reserves 100 sigops for the Coinbase transaction. So when you're building a block, you're putting transaction into it, you have to add a special transaction kind of at the top of the heap called the Coinbase. And Bitcoin Core kind of has some automated stuff to do this for you, and it just leaves 100 sigops for the Coinbase, period. My understanding is that F2 Pool had written a custom block building like template where they were no longer reserving 100 sigops for that. They were reserving like 1 or 3 or some like tiny number, and they miscalculated how much they had left off for themselves or something and went over. So that's which twice, and then they fixed it. I assume, one presumes they fixed it, yeah. The Stack Overflow post that I read, which is clearly correct, like I did not verify, I apologize. Oh. I think Andrew might be able to answer this for us. Okay. I'll repeat it, yeah. So what Andrew is explaining is when they were designing TapScript, which was what that so what we're referring to is my slide where I had check sig add, which is a TapScript only opcode. So one of the problems with this sigops stuff is that whenever you're creating a cost for a transaction, you're usually counting the number of bytes in the transaction, right? And you pay based on the number of bytes in the transaction. The sigops limit is like a separate requirement for a kind of a constraint on what transactions are allowed to go inside a block. So suddenly you have the kind of a two-dimensional optimization problem, is what Andrew was saying. Andrew, I think I'm doing, yeah, okay. And the problem is that now you have, you kind of have to get less sigops, but more bytes, whatever. So they tried to unify both of them for the taproot, and the way that they did that is for every sigops, you must have at least 50 bytes of weight. So rather than looking at the sigops limit, you now say, okay, so you kind of like get rid of the limit of sigops. You're not counting sigops anymore. You're just saying every sigops appearance in a script must have 50 bytes of weight that you're paying for in the general transaction. So it changes it from this weird accounting thing to this opcode has a weight requirement of the rest of the transaction. And I think that's pretty easy to hit if you have a signature, because you usually, most signatures are 64 bytes. So is that right? Yeah, I think signature is 64 bytes in Taproot. So if you have a 50 byte requirement along with a signature operation, like you're always, by definition, if you're providing a signature, you're always going to go over the limit. And some of the ways that TapScript scripts are now constructed, you could wait, but what about the slide about the if op else stuff, right? That could get you in trouble because you wouldn't provide a signature for an op check sig and an if branch, right? So if you're still counting those as 50 byte weight, then you might still run into problems. I think the way that you would solve that is in TapScript. The way that the Merkle roots are constructed, you're generally going to, the way the Merkle roots are constructed, you're generally probably not going to be having if statements and scripts anymore, because you're able to do more complicated tweaking of exactly which script you want to reveal. And so hopefully with all these things together, you would really never run into a situation where you have more signature operations than bytes, I think. I don't know. Cool. Okay, I think I'm definitely over time now. Thanks, everyone. Please enjoy your coffee. Yeah.